Let me explain to you the time-based approach using another convolution encoder, okay? And this time I took another step, little bit more difficult, alright? Here, if you look over here, construct a 3-to-1 convolution encoder. My question is incomplete, okay? Now itself I'm saying the question is incomplete because I want you all to first understand the question and then we'll try to write the answer, okay? So here the question is construct a 3-to-1 convolution encoder. The question is incomplete, right? And now I'm going to express. So when you're looking at this, you need to understand you need to look at the generator sequence. I have not written the generator sequence over here. My question is incomplete. I have not written I need to express my generator sequences, okay? But before expressing the values of the generator sequences, I need you to understand what are the generator sequences over here. See, look at the value of n, look at the value of k, and look at the value of m. The value of n is equal to 3, the value of k is equal to 2, and the value of m is equal to 1. And so let me ask you this, how many outputs are there? There are 3 outputs, right? So 3 outputs, am I correct? There are 3 outputs. So 3 outputs means, let me write those 3 outputs. You will have, since there are 3 outputs, you will have g of 1, okay? You will have g of 2, okay? And you will have g of 3, right? Since there are 3 outputs, you will have g of 1, g of 2, and g of 3, okay? Now look at the interesting thing about this. How many input are there? There are 2 input bits. The value of k is equal to 2, which means there are 2 input bits, right? So 2 input bits, and the value of m represents the number of shift register blocks. And the value of m is equal to 1, which means there is only 1 shift register block. But since there are 2 inputs, so like I said, the number of shift register blocks per input. So since there are 2 shift register blocks, since there are 2 input, each input, alright, each input will have its own shift register block. So therefore, even though the value of m is equal to 1, the circuit will actually contain 2 shift register blocks, 1 for each input. Okay, that is why this 1 means. 1 means a number of shift register per input. So this 1 means 1 shift register block for each input. So since there are 2 inputs, there will be 2 shift register blocks, right? So since there are 2 inputs, you need to express those 2 inputs in your generator sequences. So therefore, this is not simply g of 1 or g of 2 or g of 3. Okay, you need to express them in terms of 2 inputs. So I will call that as g1 of 1. You will have g1 of 1 and you will have g2 of 1. Okay, which means these two represents the first output value, but regarding the input side, this represents the first input, this represents the second input. Both of them gives the same output, right? Both of them will be the combined answer will be given to the first output. That's what this means. Look at this, g of 2, which means you will have g1 of 2 and you will also have g2 of 2. Okay, likewise you have g1 of 3 and you will also have g2 of 3. Okay, so I want to understand, these are the generator sequences that you need to have, or you need to know if you want to draw the encoder, right? 3 outputs, so therefore there will be 3 generator sequences, but each sequence has 2 generators, or 2 generator sequence. One to represent the first input, the other to represent the second input. Okay, that is what this suffix 1 means. 1 represents over here as the first input, 2 that represents over here represents the second input. All right, so now let me write the question. So this is the question, that is g, what is the value of g1? Let me see, the value of g11 is 1 1. Okay, the value of g1 of 2 is 1 0, and here it is 1 0 again. All right, and the value of over here g2 of 1 is 0 1. Over here it is 1 1, and here it is 0 0. Okay, So this is the question. So okay, before I just want to tell you, because before writing the question I need to understand, I want you all to understand the question. So here this is how the question will be asked. Construct a 3 to 1 convolutional encoder whose generator sequences are given by G1 of 1 is equal to 1 1, G2 of 1 is equal to 1 0 1, G1 of 2 is equal to 1 0, G2 of 2 is equal to 1 1, G1 of 3 is equal to 1 0, G2 of 3 is equal to 0 0, right? And remaining question is, and find the output when the information sequence is U is equal to 1 1 0 1 1 0. Here the length of L is equal to 1 2 3 4 is equal to 6, right? Here the length of L is equal to 6. Okay. Oh, I forgot to tell you. What does this mean? What does this mean? You'll get confused. Like I said, I told you that the number of output bit is 2, right? I told you that the number of output bit is 2. But here you can see there's only a single information sequence over here. What this actually means, okay? Don't get confused. Even though the question is like this, what it actually means is that U of 1 is equal to 1 0 1. The first bit out of every input values, the first bit, and U of 2 is the second bit out from every input values, that is 1 1 0. Okay, so either in the question they will give the information sequence like this, or they will give you the information sequence by giving these two sequences. Anyway, you should never get confused, right? So in any way you said, always remember that the number of the input bit is 2. So number of input bit is 2. What does that actually mean is that at a single time 2 bits will enter the circuit. Okay, at a given time 2 bit will enter the circuit. Which are those 2 bits? First one will enter the circuit, then 0 1 will enter the circuit, then 1 0 will enter the circuit. Okay, and for every 2 bits that enters the circuit, 3 output bits will be generated simultaneously. Right, 3 output bits will be generated simultaneously. So now enough of this. Now let's draw the encoder. So to draw the encoder, okay, so to draw the encoder, what I'm going to do is I'm going to draw the, so since the value of the k is equal to 2, there are 2 inputs, right? So let me draw those 2 inputs over here and over here. So this is U of 1 and this is U of 2. Okay, this is U of 1, this is U of 2. Maybe I'll just draw a switch also over here. So in that case, this is called as U. Okay, so means what it means is that first 1 will be transmitted over here, and and then the switch will change its position, and the other one will be transmitted over here. Then the switch will change its position, and 0 will be transmitted over here, and then change position over here, and then 1 will be transmitted. You see, that's how it changes. So for every at a single given time, the value of the switch U changes in both position 1, position 2. So the first bit will enter here, the second bit will enter here. Okay, so since the value of M is equal to 1, there is only one shift register block for each input. So what I meant is this is the one shift register block for U of 1, and this is the other shift register block for U of 2. Okay, there you go. Okay, so this is what it means. This means k is equal to 1 and m is k is equal to 2 and m is equal to 1. Now next what I'm going to draw is, I'm going to draw the 3 outputs. Yeah, I forgot. Let me draw the 3 outputs. So how to draw? I put it over here. This is V of 1. This is V of 2 and this is V of 3. Okay, and since there are 3 outputs, you will have 3 XOR functions. Okay, you will have 3 XOR functions. So this is V of 1, this is V of 2, and this is V of 3, and then and of course you need a switch that changes its 3 positions, right? Yeah, and this combined output you call it as V. So this is at the output side. Next what I'm going to do is I need to express each of these functions, and I'm going to do that by looking at the generator sequences. Okay, you know what I'm going to do? I'll use different pen, okay, just so that you will understand how it is being done. I will use whichever the different pen I have. I'll use green, I'll use orange, and one more pen also I need. Can I use black? Or I'll use red. Alright, so these are three colors. So first I'll use G1 of 1. Okay, G1 of 1 is equal to 1 comma 1. Okay, and also G2 of 1 is equal to 0 comma 1. Okay, this will be green. G1 of 2 is equal to 1 comma 0, and G2 of 2 is equal to 1 comma 1. I use red pen. G1 comma 3 is equal to 1 comma 0, and G2 of 3 is equal to 0 comma 0. 0 comma 0 means no connection at all. Alright, so now let's draw first I will draw the first output, value of the first output. So what is the value of the first output? 1101. That is, in the first input or in the first shift register block, it is 11. In the second shift register block, it is 01. So first shift register block is 11. 11 means this is 11. There you go. This is connection over here and connection over here. This means 1 1. Okay, and over here in the second shift register block, it is 0 1. 0 1 means there is no connection over here, but there is connection over here. So I will just connect it like this, right? Okay. Okay, so this is called as 1 1 1 1. This is 0 1. 0 1 means no connection. 0 1. 1 1 0 1. Okay, now let's talk about the second output. So second output means I need to look, this is G1 of 2, this is G2 of 2. Like that I can draw the value of V of 2. Okay, so what is the value of G1 of 2? This is respect to the first shift register block. This is with respect to the second shift register block. So the first shift register block, it is 1 0. 1 0. 1 0 means this is 1 0, this connection, right? That means it's from here and not from here. It's from here. So this is 1 0 1 0. So I will just draw like this. Okay, right? 1 0 1 0. 0 means no connection from here to here. 1 means connection from here to here. 0 means no connection from here to here. And here is next is G2 of 2 is with respect to the second shift register block, it is 1 1, which means there's connection from here to here, and also there's connection from here to here. That's what it means. So I will draw that. So so far I said the first connection will be from here. So I will draw from here, and I will go like this, and I will connect right here. Okay, this is 1, and second also there's 1. So which means here also there's connection. So how to draw the connection? I think I'll take it from here, right? Why complicate things? There you go. Okay, so this is how we draw the with respect to V of 2 by looking at this value and this value. Now I'm going to draw the value of V of 3. So V of 3 means this is with respect to the first shift register block. This is with respect to the second shift register block. Okay, so this is 1 0. 1 0 means 1 0 actually means nothing but from here, sorry, I'm sorry, it's from here 1 0, which means there's connection from here, but there's no connection from here. So only from here, and that's what you see over here. That's it, 1 0. Okay, and with respect to the second shift register block, it is 0 0. 0 0 means there's no connection from here, there's no connection from here. In other words, V of 3 has nothing to do with the second shift register block, because both the values are 0 0, which means no connection from here and no connection from here. Okay, and but V of 3 is only having 1 over here, which is this is the with respect to the first shift register block, which is this point right here, this point right here. Okay, right, so this is your 3 2 1 convolutional encoder. Okay, so now I'm going to explain to you the time-based approach, right? And time-based approach of this is extremely easy. All you need to do is, just like in the previous case, all you need to do is find the value of v of 1, then you need to find the value of v of 2, and then you need to find the value of v of 3. And what is the value of v of 1? Well, since in this example there are two inputs, right? And what do you do with those two inputs? You just simply add them. That's all. All you have to do is simply add them together. Or in other words, you multiply u of 1 with this, okay? And then you multiply u of 2 with this. That is, you multiply u of 1 with the generator with respect to the first input, and then you multiply u of 2 with the generator sequence with respect to the second input. Or in other words, v of 1 is equal to u of 1 into g1 of 1 plus u of 2 into g2 of 1. This is how we find the value of the output values, right? Since there are two inputs, the respective sequences will be with corresponding to those two inputs, right? So this is the generator sequence, this is the first output generator sequence with respect to the first input. This is the first output of the generator sequence with respect to the second input. In the same way, v of 2 is equal to u of 1 into g1 of 2 plus u of 2 into g2 of 2, where g1 of 2 is the second output generator sequence with respect to the first input, and g2 of 2 is the second output generator sequence with respect to the second input. So that's why you multiply the first input with this and you multiply the second input with this. In the same way, v of 3 is equal to u of 1 into g1 of 3 plus u of 2 into g2 of 3, which means g1 of 3 is the third output generator sequence with respect to the first input, and g2 of 3 is the third output generator sequence with respect to the second input, right? That is why you multiply the first input with this and the second input with this. So this is the equation for v of 1, v of 2 and v of 3, okay? So let's find these values. So v of 1 is equal to, what is the value of u of 1? This is u of 1, 101. So here you basically do is you multiply 101 into g of 1. What is g of 1? G of 1 is, g1 of 1 is 1 1 1 1 plus u of 2 is 110 110 into, and what is g2 of 1? G2 of 1 is 0 1 0 1. You just simply multiply them and add them together. That's it, right? This is how you do. This is the calculation. Okay, so that means, let me find the value quickly. 101 into 1 1, and you will have 101 and 101, and you will get 1 1 1 1, and here it is 110 into 0 1, and here you will get 110. That's it, right? 0 0 0, and you will get 110. So you will get 0 1 1 0, right? You will get 0 1 1 0. See, my answer is correct. Alright, so anyway, so yeah, in other words, what you get is, you will get nothing but, what you do is, now you simply need to add both of them, right? 0 1 1 0. So when you add both of them, what you will get? That is, you will get, here you will get 1 1 1 1 plus, and here you will get 0 1 1 0. So when you add both of them, you will get 1 0 0 1. Okay, adding means, don't think it's binary addition, this is XOR function. Okay, so you will get 1 0 0 1. So this is the out value. You will get 1 comma 0 comma 0 comma 1. This is the value of v of 1. Next you will find the value of v of 2. Okay, the value of v of 2 is, what is the value of u of 1? 101 into, what is the value of g1 of 2? The value of g1 of 2 is 10 plus, what is the value of u of 2 is 110 into, what is the value of g2 of 2? The value of g2 of 2 is 1 1. So multiply that now. 101 into 10, and you will get 0101, and you will get 1010. So 1010 plus, next you need to multiply 110 with 11, and you will get 110 110, and you will get 0101. So 1010. Wow, all zeros, right? Because 1010 plus 1010 is nothing but XOR function. So XOR function means that everything will be 0. So this is the value of v of 2. So value v of 2 is 0, 0, 0, 0. Next is the value of v of 3. So how to find the value of v of 3? V of 3 is equal to u of 1, which is 101, into g1 of 3. What is the value of g1 of 3? It is 10. 10 plus u of 2. What is the value of u of 2? It is 110. 110 into g2 of 3. What is the value of g2 of 3? It is 00. Wow, 00. Okay, so let me multiply this. This is 101 into 10. I think I already did that, right? Yeah, it's over here. 101 into 10. I'll get 1010. So 1010 plus, and this is nothing but multiplying with 0 itself. You will get 0000 itself. So you will get, adding both of them, you will get 1010. So this is the value of v of 3. So now you found the value of v of 1, you found the value of v of 2, and you found the value of v of 3. Okay, we put a bracket over here. Now, so what is the value of v? That is the interesting part, right? What is the value of v? The value of v is, here you can see that there are 3 outputs. Why are there 3 outputs? Because the value of n is equal to 3. So which means a single output value has 3 bits. A single output value has 3 bits. Okay, that is, this is the first bit of v of 1. This is the first bit of v of 2, and this is the first bit of v of 3. Okay, so it means the first output value is 101. Okay, this is the second output, this is the second value of the first output. This is the second value of the second output. This is the second value of the third output. This is the third value of the first output. This is the third value of the second output, and this is the third value of the third output. This is the fourth value of the first output. This is the fourth value of the second output, and this is the fourth value of the third output. This is the value of your output. That is 101, 00, 001, 10, right? That's it. This is the values, right? So here you can look over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12. Number of output bit is equal to 12. You can look over here that the information sequence, right? The information sequence is 6, 1, 1, 0, 1, 1, 0. But now this information sequence has increased to times 2 times 2. Why? Because this because the reason is because there are 2 shift registers, and after applying them you need to apply 1 0 over here and another 0 over here. That is why you get 2 different extra answers, or the remaining extra answers you are getting is because of that. So this is the output value. Okay, now if you are interested in constructing using the generator matrix, okay, they can ask that also in the exam. So if you want to construct this generator matrix, or if you want to find the value of v, you need to know the value of u, and you already know the value of u. The value of u is 110110. So you need to construct the generator matrix. So how to construct the generator matrix of a 3-to-1 convolutional encoder? That is also, like I told you, the process is very simple. That is, the generator matrix has L rows. Okay, the generator matrix has L rows. Here, what is the value of L? The value of L is over here is 6. You can say it in two ways. There are two ways. You can either say that the value of L is equal to 6, or it depends on how you are thinking. You can either say that the value of L is equal to 6, or you can say that the value of L per input sequence is 3. Okay, you can say in two ways. That is, the value of L is equal to 6, and that is the value of the length of the information sequence. Or you can also say that the value of L is equal to 3 per input bit, or per information sequence, right? Like that you can say. So here I'm going to say the value of L is equal to 6 rows, all right? 6 rows, okay? And all, now if you ask me how many columns are there, that does not change. The number of columns will be n into m plus l, okay? N into m plus l columns, where m represents the number of shift registers, which is 1, plus the value of L is equal to 6, and here you will have n is equal to 2, right? The value of n is equal to 3. So let me see first. Let's see if this is correct or not. Okay, let's do this question, then we'll see if it's right or not. So anyway, let me just do this question. So here the value of G is equal to, so there are 6 rows, right? When you need to understand how those rows are being represented, it's much more important. Anyway, 3, 4, 5, 6. There you go. 6 rows, right? How to represent the first row? The first row is over here. That is, let me see, it is G11. Let me write that first. Oh, this might be confusing for all of us. G1 of 1 is equal to 1 1. G2 of 1 is equal to 0 1. G1 of 2 is equal to 1 0. G2 of 2 is equal to 1 1. G1 of 3 is equal to 1 0, and G2 of 3 is equal to 0 0. Okay, right. Okay, so let's write the output. So here the output is, first output will be, the first value so will be the respect to the first input bit, right? So I'm going to write the output. I'm going to combine the output with respect to the first input bit. The first input bit means, what are the first values of the first input bit? It will become 1 1 1, right? 1 1 1. So 1 1 1. Next it will be 1 0 0. 1 0 0. There. This is your first row. Okay, but it's not complete. You see, that's what thing is, because since the number of input is equal to 2, you need to write with respect to this also without shifting. So this will become 0 1 0 0 1 0 0 1 0. The other will be 1 1 0 1 1 0. There. This is how we express the first 2 rows of a 3-2-1 convolutional encoder. Okay, now the rest of the theory is same. That is, now if you want to write the next row, you need to shift the branch word you need to shift the sequence by a single branch word, and here the number of bits of the branch word is equal to 3, so you need to shift it by 3 bits. So it becomes 1 1 1 1 0 0. Another time it becomes 0 1 0 1 1 0. Okay, and again next time you're going to shift it. So you need to understand why there are 2 of them. Okay, 2 of them in a single pair. That's because the value of k is equal to 2. Okay, that is why the value of k is equal to 2. So we say that with respect to the on the first shift register and on the second shift register. This is the values of the one side of the shift register. This is the values of the other side of the shift register. That's for the shift register of the first input. This is the shift registers of the second input. This represents the input of the second shift register. This represents the output of the second shift register. So here again I have to write, again I am shifted, so it becomes 1 1 1 1 0 0. Here it will becomes 0 1 0 1 1 0. Okay, that's it. This is it. The remaining blank space that you see anywhere, you just simply put zeros over here. 0 0 0 over here. Here also 0 0 0. Here it will become 0 0 0 0 0 0. Here also it becomes 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, so this is how you get it. This is how you do it, right? This is how you do it. So this is how you use the values of the generator matrix, right? So now let's see how many rows are there. 1 2 3 4 5 6. There are 6 rows, and also there are, if you look over here, there are 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so which means there are 12 rows. So 12 rows means how do you get it? Let me see. So so that means it's not 6 actually, it's 3. Right, it's not 6, it's actually 3, because the length of the information, this calculation is done based on the information sequence per input. So here it is 3, right? So you will get so the value of n is equal to 3 into, let me see, what is the value of m? The value of m is 1 1 plus 3. Correct. Yeah, it's correct, right? So you'll get 3 into 4, which is equal to 12. Exactly, you'll get 12 rows. Okay. So that means, so you need to remember that, okay? That's when you're going to calculate the number of columns, the value of L is not the length of the total information sequence. It will be the length of the information sequence, per input, okay? For a single input. That is why it is 3. So you get 12 columns. So this is how we express it. Now, when you apply V is equal to U into G, when you apply V is equal to U into G, where U is nothing but this information sequence 110110 110110. Okay, when you multiply 110110 with this matrix, you will surely get the same answer. Okay, I want you all to do this for homework. Okay, show this. Multiply U with this G and you will get the same answer over here. U is this value. Okay, so this is how we explain the convolutional encoding using time-based approach.